today I intend to give you a brief background of what environmental geomechanics is all about, and this is in lieu with the discussion which we are having in the previous lecture, that what is the significance of environment and geomechanics put together, and lot of questions which you had in your mind. So, this is a 202 course with 6 credit units, and my contact details are given there, already known to you. And just to give you the overview of this course, I define this course as an engineering philosophy, and the genesis of this course was I have been teaching soil mechanics, engine mechanics, foundation engineering, advanced soil mechanics to different levels of students, and then this idea came to my mind that why not play with the conventional subjects and create something new. In fact, the prompting was done by my undergraduate student who was sitting in the class, and he prompted me to develop something new. So, this was at the back of the mind to create something interesting and something which is unconventional, and that was the genesis of this course. So, why I call this as engineering philosophy? Very soon you will realize that most of the discussions which I am going to do in this interaction are based on some premise, and basically when you create a premise, this is nothing but a philosophy, and it so happens that most of these philosophies we find them happening in real life. Okay. So, my emphasis of our discussion would be to showcase how the philosophies can be realities in life, and that too when we talk about the engineering philosophies. So, to answer your question quickly, Vikram, I suppose you asked this question in the last lecture, that why environmental geomechanics. So, truly speaking, we are trying to either incorporate the influence of environmental activities or effects on the systems, either this could be man-made or this could be natural, on conventional geotechnical engineering concepts and practices. So, if you check the internet, you will find that most of the western universities, they do not offer civil engineering as the courses right now. They basically talk about the man-made structures or built environment. So, the present day context is built environment. The connotation is that the built environment is the one which is created by human beings, and we along with our systems which we create coexist in the environment, and subsequently we will see that the environment itself could be either man-made or natural. All right. So, if you look into this, like our great grandfathers, they used to live in caves, and most of the time these caves were naturally built. Of course, they might have created caves also, and then the caves are the best examples of where the soil, rock, water, environment interaction takes place, because most of the caves either are leaking or they get frozen, or they get debris flow, or they may have seen the collapse of the walls because of the movement of tectonics. All right. So, all these possibilities are there. So, basically what we want to do is we want to study how the environment is influencing the structures which are either natural or which are man-made. So, when I say this, the scope of the studies become quite diversified. So, anything which is happening under the sun is our focus of interest, because sun also is a part or attribute of the environment. Why? Right now the humidity is very high in cities like Bombay, is it not? Because there is no sun. So, disappearance of the sun is an attribute associated with very high humidity. Now, when very high humidity occurs, how the systems which are created in the soils are going to behave. This is what I would like to study, or in other words, how the soils will respond to this type of a system where the humidity level is extremely high. The reverse could be the situation 2 months back when there was no humidity, it was extremely hot, all right, sun was on its full glow, how the soils were responding, how the structures are responding. So, these type of extreme climatic conditions or the environmental conditions, one has to study if you really want to do good engineering and if you want to avoid failures. So, basic theme of our discussion is how the environment influences the structures, and this is what we will put up in the form of a philosophy, and then we will try to visualize how these philosophies really work in real life situations. So, it so happens that this is becoming a very trivial situation for all of us who are dealing with issues like municipal solid waste, I would say, all right. Or suppose if you have to do engineering in the regions which are quite difficult to work on, problematic soils, marshy lands, coastal environments. So, these are the situations which are very tricky. So, when you come out of the realm of the areas where already enough construction rehabilitation has been done, and when you focus on the areas which have not been touched yet, we call them as virgin lands. And why they are virgin? Because human activity could not influence them. In conventional geomechanics, we gave them a term as problematic soils. Now, subsequently we will study there is nothing known as a problematic soil if you are a technologist. You understand why? Because I can negotiate with the situation. So, the problematic soils can also be trained very well provided I know how to deal with them. So, this is the context in which we try to study environmental geomechanics. Clear? The places, the situations which were never studied earlier, which were supposed to be quite hypothetical few years back, are now becoming very practical. And then there is a pressure from the society that somebody has to give the solution for these problems. How and when and in what form these solutions can be given would be a challenge. So, this subject is gaining significant attention of engineers, researchers and planners due to rapid and uncontrolled industrialization. Industrialization is the main problem. The more and more industrialization, the more and more so called pollution, the more and more population load. When all these happens, what happens? There is a scarcity of the land. Look at the city like Bombay. Everybody wants to come and settle down in a city like Bombay, all right. There is a scarcity of the land. So, when there is a scarcity of the land, what would be the best possible solution? You go to the places which remain untouched, which I was talking about, marshy areas, all right. The salt pans which people did not consider earlier for construction. Either the techniques were not there, or the courage was missing, or it was the ignorance of the people. Clear? Whatever the situation could be. So, this is because of the rapid and uncontrolled industrialization. I will cite several examples where how industrialization is causing a major stress on the society and on the professionals like us. This will become clear. So, when we talk about the uncontrolled industrialization, there is a huge amount of hazardous waste which is being generated, and the question is how we are going to deal with this. So, when we talk about the hazardous waste, one of the attributes of the hazardous waste could be the presence of contaminants. I am sure all of you must be aware of this. Now, if you look at the dictionary meaning of the word contaminants, is something which is not acceptable, not welcome. So, in a system, when you are sitting very comfortably over here, suppose power goes off, or suppose a fly comes or an insect comes. So, it is not a very rosy situation, very comfortable situation, all right. So, that particular object becomes a contaminant. So, similarly, when we talk about a very big larger sphere, say biosphere, I will be talking about what is biosphere. The presence of elements which are not welcome would be a contaminant, alright. So, how you are going to deal with the contaminants is going to be a big question. What is the attribute of these contaminants is also going to be a big question. Now, this subject is a blend of geotechnical and environmental engineering, and just coming out of my mind, I just tried to amalgamate the two subjects, and it is up to you to decide how it was created. So, I am just trying to serve to you what has been done until now, and this would deal with the studies related to safe disposal and handling of the waste. But before I go into all these things, I have to create a lot of ground to make you understand that what are the situations which you can take into account, which become very handy, so that we can talk about disposal of the waste and come out of your understanding of the waste, which is only MSW. So, the more and more industrialization takes place, countries like India are becoming superpower. So, more and more atomic activities are happening, alright, and the question is, who is going to handle the waste which is coming out of not only the municipalities, which everybody is aware of, the waste which is coming out of your industries, the waste which is coming out of your research units, the waste which is coming out of the atomic establishments. I hope this point is clear to you. So, we are not talking about only the municipal solid waste, which has become a very bottom line situation which everybody is aware of. So, let us keep this word waste in the inverted quotes. So, we would like to study how safe disposal and handling of the waste can be done, estimation of its spread and fate in the subsurface. Subsurface is nothing, the one which is, or the domain which is below the ground level, which you may say. So, when I say subsurface, the connotation is rocks, soils and the groundwater, clear. And I am sure with the basic knowledge of geomechanics which you have until now, it might so happen that the rocks might be intact, or they could be weathered, or they could be fragmented, they could be highly fractured. So, I have created different scenarios. So, within few seconds what I have done, from subsurface I have created another category of the subsurface, which could be intact rock mass, which could be weathered rock mass, which could be disintegrated rock mass, which could be fractured rock mass, and so on. Number 2 would be the soils. I am sure you are aware that the soils could be of different types, alright. They could be clay, they could be silt, they could be gravelly material, they could be bouldery material, they could be mixture of all these things, and so on. So, I am sure you must be realizing I am creating more and more situations in the subsurface, because each of these term corresponds to it has a connotation. So, the moment you say SM type of soil, you have a connotation, engineering properties are intact, clear. The moment you say CL, CI, you know what type of soils you are talking about. Another situation could be rocks and soils, they could be partially submerged, they could be dry, they could be saturated, and so on. So, imagine how many types of situations have been created within the subsurface. And of course, the third parameter or the attribute would be the groundwater. So, essentially when we talk about the subsurface, we talk about rocks, soils, groundwater, and in this domain there could be a presence of the contaminant. So, contaminant becomes a foreign body which is not acceptable, which is not welcome, and we want to understand how the presence of contaminants is going to alter the overall characteristics of itself first of all, or the subsurface. Is this part clear? So, this has become a big matrix. I have talked about the material properties, I have talked about the situations, I have talked about how this interaction is going to occur between a foreign element which is not welcome into the subsurface, which normally in technical language we define as porous media. So, the attributes of the porous media are soils, rocks, groundwater in different forms. So, we will try to study how to estimate the spread and fate of contaminants. Now, fate is the word which is normally used for human beings. People have this habit of going to astrologers, palmists, face readers. What for? They want to know their fate. Is this correct? But here we are using the word fate for contaminants. Why? Any clues? Yes, exactly, you are right. So, we want to understand how this is going to behave in the future, how what is the fate means, what is going to happen to this system. So, the system might be having both together. So, it may so happen that the contaminants are detrimental to the porous media, or otherwise also the porous media might be detrimental to the contaminants. The contaminants could be so aggressive that they may eat up the porous media. A good example is if I take acids and if I flush them from my laboratory, all right, and suppose the subsurface soil happens to be organic in nature, what is going to happen? So, this acid is going to interact with the organic material, and then this interaction is going to result into something. So, what is the fate of the system? Something is detrimental to another, clear. So, this type of situation is becoming very, very prominent in most of the industrial activities which are happening in today's world. The second thing which we will talk about is the methods to contain its spread. As a geotechnologist, environmental geotechnologist, I would like to avoid the situation to occur where the contaminants are going to spread in the entire subsurface. How to do that? Curtail the spread, containment. So, we will talk a lot about the containment of the contaminants, all right. And suppose if I fail in containing the spread of contaminants and the geomaterials or the porous media or the subsurface gets contaminated, how would I remediate it? So, I am sure within one slide which I have shown you, I have taken you from different levels to different levels. By the time we started from philosophy, and I have created several situations by the end of this statement.